This is our third and final example for 5.4 day 2 about equation solving using the multiple angle identities. Now in this case we're going to use the power reducing formulas, and I've mentioned to you before, only use power reducing when it says in the directions to do that. Now there's a little bit of a weird thing going on here in the book problem like this. In the book problem it says to use half angle formulas, and I'm not sure why it does that. This is going to be on number 43, and I want you to make note of that before you go start your assignment. Is number 43 gives you the wrong directions. On 43 you should use the power reducing formulas to solve this instead of the one that is directed in the book. So please make note of that. Definitely use power reducing, and like I've said before, only use these when you're directed to do so. So it's important to have the right directions here. We're going to find the exact solutions again on the interval 0 to 2 pi as we did before. We start with this right here. Now there's some things that we have to do with this. We use the power reducing identity, but notice here that we got cosine squared x over 2. This one's kind of a weird one, so we want to somehow free this up. This one's okay. We're used to working with sine squared and just a normal variable, so let's see if we can use this to make things a little bit easier on us. For that, I'd like to refer down to this cosine squared formula. This is a power reducing. You might be thinking, well, it's x divided by 2, so it doesn't work very well. But this x over 2 is precisely why this is going to work well. So we're going to have that x over 2, that x over 2 is going to represent our u in the formula here. So that's the u that you see down here in the formula. That's a good thing, because when we put that in now, it's going to be taken care of. Now I'm going to just leave the sine squared over here. Just going to simplify, put in the formula for this side here. So it's going to be 1 plus cosine 2u. Now u is x over 2, so as you might notice, that's going to turn out kind of nice. All this divided by 2, by the way. Those 2's are going to cancel out, and that makes things much simpler to work with, and that's why the power reducing is going to be a good idea. The reason that people get kind of mixed up with power reducing and the other multiple angle formulas is because sometimes it makes it more complicated. If it makes it more complicated, we want to avoid it. Now that cancels out the 2's, but also we should multiply both sides of this equation by 2 so that we can get rid of the fractions. And so multiply that by 2, and we get 2 sine squared equals 1 plus cosine x. And that's not terribly difficult to work with. What we're going to do with this is we are going to rearrange this equation so that we have everything on one side to start with. So let's move the 2 sine squared over to the other side. We get 0 equals negative 2 sine squared x plus cosine plus 1. I'm just kind of writing them in order so it's easier to work with later on. But we want to factor this, and we worked with some factoring patterns earlier on in the chapter. The problem here is that they have to be consistent. We have to have either sines or cosines, but not a mix of both. So what we're going to try to do is change this to make it a little bit better. I'm going to go up here. So one way we can do that is by thinking about the Pythagorean identity, which is sine squared plus cosine squared equals 1. We can rearrange and find what sine squared is by subtracting cosine squared. So sine squared is going to be equal to 1 minus cosine squared. And we've talked about that a little bit before. But we're going to replace that in order to get all cosines going throughout this problem. So let's do that here. 0 equals negative 2 times 1 minus cosine squared, and then plus cosine plus 1. Okay. Now we distribute the 2. Negative 2 plus 2 cosine squared plus cosine plus 1. Then, of course, we need to combine like terms. Let's write this all in standard form in the correct order. And so then the 2 cosine squared is going to go first. Cosine is going to go second. And then we have actually -1 right here. So we've got this now written in standard form. This is one that we can actually factor like a quadratic. So if we factor this like a quadratic, just going down here, maybe just a side note, this would look like 0 equals 2x squared plus x minus 1. We're going to think about it like that. Now, if you're going to factor this, it's a little bit of guess and check going on here, but here's what the factoring would look like. It would be 2x, it would be 2x minus 1 and x plus 1. Because those -1 times 1 is -1, 2x times x is 2x squared, and then if you do the inside and the outside of FOIL, so we get -x and 2x times 1 is 2x, and so that makes a positive x in the middle, so that's the correct pattern. Well, that being the case, we just, instead of having x in that pattern, we do cosine for what's up here, so this one is going to be 2 cosine minus 1 times cosine x plus 1. And those are going to make up our 2 mini equations. So then we split that up and we get 2 cosine minus 1 equals 0, and we get cosine plus 1 equals 0. Got to solve those for cosine. If you do, cosine equals 1/2 on this one, and cosine equals -1 on this one. So now that we have our mini equations, we've done most of the work here. Now it's just a matter of going back to the unit circle. We're looking for x values because it's cosines. And so we start with where are the x values equal to positive 1/2. Well, I see one right here. That's negative, so not that one. That's negative down here. Here's a positive one. That one's going to work as well. So for cosine being 1/2, that means that we have x equals pi over 3 and 5 pi over 3. That's one pair of answers for this problem. And then the other one is that cosine equals -1. Well, that's, again, we're talking about the x value. Cosine equals -1. There's really only one spot for that. That's right here. It's one of our quadrantal angles. And so -1 is at pi, meaning that our other solution is x equals pi. This one only has 3 solutions. But that is, again, an example using the power reducing. Please make sure you see that on number 43. Change the directions in the book and check your answers like usual.